Thank you. Yeah. And, good morning, ladies and gentlemen. And my topic is about new generation 3D GIS technologies empowering the digital transformations. And I'm a little bit excited to share you guys about what's going on in our research. And as we all know, for more than over 40 years, GIS have helped users to manage, analyze, and map all types of data and improve information and efficiency as well as better management and decision makings. From them, 3D GIS improves evaluations and decision making with realistic visualizations and advanced analysis, and all of them have help the users to uncover the full potential of geospatial data or versatile industries. But now, the traditional survey and mapping is as we all know, is very quite time-consuming and low efficient. And with the new and rapid development of surveying and mapping technologies, and we see this picture, drones are widely used in surveying, and it provides precise data much faster than the traditional ways. So it's produced 3D data as well. So it's a very clear trend that the data efficiency will be much faster than ever before. Let's check out this video. And as we see, as a result of the new surveying and mapping technologies, more precise data, 3D data, as we can show, is more realistic, and now it's become available and more efficient than before. So based on the 3D terrains, author photos, and real-time hydrogeological data, which can present the water level of the waste, then the waters pass through. And we can have the decision makers to monitor the flooded areas, and all of them could assist in response to the emergencies, to the flood disasters. And here's another case. It's about the emergency response in the case of the forest fire. So we can access to the real-time drone video, and we can see it combined with the surrounding environmental data, so we can monitor what's foreseen the forest fire situations, and then could help us to know what exactly happened in this area. And as for today, I will show you the following 5 aspects. The first one is a complete spatial data model system, and I think it's prerequisite for constructing the whole 3D scenes. After more than 10 years of development, we have gradually built a 2D and 3D integrated spatial data model system for the full space representations, modeling, and analysis, including the first one, the object models, and describing can be used to describing the discrete spatial features. And the second one is the network models, and which has the topology features. Can describe the link between the relationship between such as the pipes and the pipe points. And the third one we call is the field model, which could be used to represent such as the terrains or the spatial temporal phenomena. The first one is the object models, and the Supermap GIS platform can manage the traditional 3D models, such as the models from 3D Max or others from the BIM software. Here's the next data model that we call the 3D network models, which is widely used in the underground networks. The third one is about the field model, and what we did in 2018, we upgraded the 2D grid to the 3D data model, as we call it the voxel grid. And the raster surface model could be display and store the full-time data informations. And as we see in this picture, we can see the distribution of the atmosphere or certain oxygens and how it's distributed from the time or other aspects. And here's another cases we use in telecommunications. We can overlay the field model over the buildings so we can see the distribution of the signals, and which help to optimize the network. As for the modeling capabilities, we have the two ways. And the first one, we call this parametric modeling, which is very quite effective. And the third one, we call this interactive modeling. We can modify the models as for the orientations and the skills, so we can make it more flexible. So we can use this technology to build or generate the pipelines for the tube-wire modeling, as we see in this picture. Yeah, the tube inside the well. And we can still use, here an example of how about the road design with the original design scheme, and we use this road center line data and the 3D road model could be automatically generated. Another example is about the building draft design. The 2D, as we see in this the left picture, the 2D architectural design plan coupled with the corresponding plan rules, and the buildings and parking lots could be generated in the 3D models. And now, this year, we make all these technologies more faster, so we can create a massive city at once just by one click. And we could provide more architectural structures such as the roofs or the parapets, and we can offer more materials such as the facades. We can divide it into different types. As for the informations, we can do this in this residential, commercial, or industries, and we can see the details of through the models. And then the third one is we can make this modeling ways more effective. It's about 200 times faster than traditional ways. Yeah, as we see in these pictures, now more types and details are provided in these updated technologies. We can see the balconies, we can see the facades, and we can see the roofs. Yeah, this is the final scenario, and we show in this in our engines. All of the buildings have some more details than ever before. The second one is efficient 3D data processing abilities. And as we see in this picture, 3D GIS help users to gain greater insights and understanding with multi-source spatial data. And now we can access high-realistic visualizations, such as the 3D mesh, point clouds, yeah, as we see in this picture. We could directly access to the multi-source data in multi-ends. Yeah. As for another fields, such as the beam data, we could directly access to the main software, such as from Revit from Autodesk, such as Bentley from the MicroStation from Bentley, and the open source data formats such as the IFC. After access to this data, we can show this more than the structure, the information, and all these materials such as the roughness and the metallic features show in these 3D scenes. And this is another case Another case we used in the smart cities. We can see the waters. We can see the environment maps overlaid in the building, and the night view. This is a very famous interest place in Chengdu, and this is Shanghai. We can see the day and night view. And another, more 3D effects to show the 3D scene more realistic. And now after show you guys the realistic effects, and what we are facing is how to handle the big data in the real circumstance, such as the beam, the oblique photogrammetry models. Let's take the oblique photogrammetry data as an example. So we have faced many data errors and unforeseen situations during the processing. So maybe one of them will cause the data processing to halt. So we have to make some actions to avoid or to make this whole processing runs more smoothly, such as due to the huge size of the file and the wrong bounding box or the triangulation errors, texture redundancy, or other situations we never seen before. And this is how we develop the full processing workflows to pre-process all the data, right? So we can reduce the halt and to increase the efficiency during the whole processing time. We used more than 100 operators to help users to process the multi-source data. The third one is about the spatial analysis capabilities. And 3D analysis now offers enhanced performance with the use of GPU, and this technology takes advantage of the parallel computing power of the graphic card. And we have to mention is the GPU analysis has no real analysis results because of its technical natures. But we invent other technologies. We can make the analysis results to be exported, so we can use it more widely during the real scenarios. This is cut and fill analysis, and we can see the results. Another is the profile analysis. We can draw a line through a building. We can see the profile lines. Another one is the sightline analysis. We just choose the points. We can see whether if the line is obstructed or can be see through. The skyline analysis, which is very clear. The special query. We can draw an area and see which building is located in this region. This is the sectioning. We draw a box and see what is inside the buildings. This is all about the analysis. Now, the first one is about the Web 3D technologies. And with constantly technical explosion, Supermap GIS has launched several Web 3D client products and has finally to form our independent WebGL and WebGPU products, and with more functions and better effects. This is a comparison about the virtualizations. And the left one is what is originally designed in the maybe in the Rabbit software, and there is no features about the materials, so only for the designers. But for the users, we could use the PBR physically based rendering, so we can see what is metallics really looks like. Let's check out this video. We can add some more 3D effects. To make the night view seems more clear. And this is another plants. We can see the materials used in the pipelines. And another one is on how we virtualize the waters. We can see the waves. which can be used to represent the lakes or the rivers. And this is we called the environmental light. The fifth one is about the integration and the GIS and the game engines. And as we all know, then if we go for the more realistic visualizations, the game engines may be a better choice. But now we can make GIS and the game engines works together. And the GIS can bring the large-scale data and the spatial analysis into game engines. And in game engines, we can see the realistic effects and more emergence. After the integrations, we can directly access GIS data in game engines. And more than that, we can do maybe after 40 spatial analysis functions in game engines. Yeah. This is another technology is about how to beautify the GIS data in game engines. Now we have have maybe a full scheme to make the old, as we say it, old data looks much better in the game engines. Now this is we have a workflow from the footprints to make the 3D models, and then give some materials and which is make them all looks better in the game engines. And here is the video. Yeah, we can see the skies, the clouds. Yeah. So after you do that, we can form more types scenes for different users. This is one maybe for the designers is about the design oriented. This one maybe for the realistic oriented 3D scenes. We can see the fogs. Yeah. Yeah, the Dingdao effects. We can see the scattering of the light pass through the trees. Yeah, this is on the very near. And also the night views. Yeah. And now we could explore more innovations and to make the users can see and feel. So we could interact with the Apple Vision Pro and this helmet. And we can see seamlessly blends GIS with the this helmet and interacts more than hands. We can use your eyes and make all the interaction and the experience more immersive. And we can, if you're interested, we can go to the booth to experience these technologies. Yeah, here is the examples, and this is totally the virtual ones, but it could be complete fused with the real ones. And this is our booth out there. And here is some use cases. This is about the military simulation and the trainings, and this is about the municipal management. Yeah, we can use the 3D data to easily access to public information with online zoning utility and parcel maps. And this is about the city planning. We can see the noise distributions. Yeah, what is going on the underground. Yeah, this. IOC about the Intelligent Operations Center for the smart cities, and this is one is to build the planning on the website, to draw lines and then to make use some parameters to build 3D models. So it could be shared. The results could be shared among the designers. And this is the one case in to build a bridge. And this is the 3D GIS, the full technology system. At the basis, we have 2D and 3D models, and then we could have a very detailed workflow for how to handle and deal with the multi-source data. And at the top of them, we could integration of the new technologies such as Web 3D engines and game engines and XRs. So all of them we could make. I think we hope to provide more values to our users. That's all for today's topic. Thank you.